about polynomials last year. The general form of a first degree polynomial is ax plus b. It contains two terms, ax and b. In ax, the coefficient of x is a. The constant term is b. Degree of this polynomial is the degree of the term ax. The general form of a second degree polynomial is ax square plus bx plus c. It contains three terms, ax square, bx and c. The coefficient of x square is a, the coefficient of x is b and c is the constant term. The standard form or general form of a first degree polynomial is ax plus b. It contains two terms. The first term is, or one of the term is ax and the other term is b. In ax, the coefficient of x is a and b is the constant term. This is the general form of a first degree polynomial. It contains two terms ax and b. b is the constant term and in the term ax, a is the coefficient of x. The general form of a second degree polynomial is see ax square plus how many terms this polynomial have? Three terms. Which are the terms? One of the term is ax square, second term is bx and the third term is c. Degree of this polynomial is 2. That is the degree of the term x square. Coefficient of x square. Coefficient of x. Constant term c.
Let us see a problem. 30 sweets were distributed equally among students. One of them said, had we been one less, each would have got one more sweet. How many students were there in the class? If we convert this into an equation, we get x minus 1 into x equals 30. Among the factors of 30, 6 and 5 are the only multiples which satisfy this condition, that is, continuous counting numbers which differ by 1 and give the product 30. 6 into 5 equals 30. So, the number of students equals 6.
I will give you a problem. If the sides of a square is extended by 1 centimeter, the area of the new square is 36 square centimeter. What is the length of the side of the original square? Can you write this in the blackboard?
Yes.
Come. Your answer is correct. If the side of a square is increased by 1 centimeter, the area becomes 36. What is the length of the side of the square? The length of the side of the original square is taken as x. The length of the side of the new square equal x plus 1. Area equal 36. That is x plus 1 the whole square equal 36. Therefore, x plus 1 equal root 36. That is x plus 1 equal 6. Therefore, x equal 6 minus 1 equal 5. That is the length of the original square is 5 centimeter. I will ask you another question. The square of a natural number is 225. Which is that number? Rayhana?
15.
Right. Sit down. The square of the numbers with 0 at the unit place is got by writing 2 zeros on the right of that number. For example, 10 into 10 equal 100. 20 into 20 equal 400. Likewise, we can easily find the square of numbers with 5 at the unit place. 5 square equal 25, 15 square equal 225, 25 square equal 625, etc.
Let us see a problem. Perimeter of a square equals 36 units. Therefore, length of a side equals 36 by 4 equals 9 units. Area of a square equals 36 square centimeter. Therefore, length of one side equals root 36 equals 6 centimeter.
Polynomials and equations are like phrases and sentences in English language. That is, polynomial have no complete meaning. A polynomial equal to 0 is an equation. The general form of a second degree polynomial is that is a polynomial. A second degree equation is ax square plus bx plus c equals 0. Ax square plus bx plus c is a second degree polynomial. Ax square plus bx plus c equal to 0 is a second degree equation. P of x equal x square plus 2x minus 168 is a second degree polynomial. Then what is the second degree equation?
X square plus 2x minus 168 is equal to 0.
Good. Arya, come and write this in the blackboard. This is the second degree polynomial. If this equal to 0, then x square plus 2x minus 168 equal to 0 is a second degree equation. P of x equal x square plus 2x minus 168 is a second degree polynomial. Then x square plus 2x minus 168 equals 0 is a second degree equation. We can form second degree equations from second degree polynomials. P of x equal ax square plus bx plus c is a second degree polynomial. Ax square plus bx plus c equals 0 is a second degree equation. This is the standard form of a second degree equation. P of x equal x square plus 2x minus 168. This is the second degree polynomial. Therefore, x square plus 2x minus 168 equal to 0 is the second degree equation. We write the second degree equation x square plus 2x minus 168 equals 0. Now we find the solution of this equation, that is to find the value of x. For this, we can write 168 to the right side of the equation. Then we get the equation as x square plus 2x equal 168. 168 is not a perfect square. For making 168 as a perfect number, we can add 1. So we can add 1 to both sides of this equation. Then we get x square plus 2x plus 1 equal 168 plus 1. That is x square plus 2x plus 1 equal 169. X square plus 2x plus 1 is a perfect square. We know the identity a plus b the whole square as a square plus 2ab plus b square. We compare the left side of the equation x square plus 2x plus 1 to the right side of the identity a plus b the whole square equal a square plus 2ab plus b square. From this we get x square plus 2x plus 1 equal x plus 1 the whole square. 169 is the square of the natural number 13. Therefore, x plus 1 the whole square equal 13 square. Square root on both sides, we get x plus 1 equal 13. Therefore, x equal 13 minus 1 equal 12. Therefore, the solution of this equation is x equal 12. X square plus 2x minus 168 equal to 0 is a second degree equation. For finding the value of x, we write this equation as x square plus 2x equal 168. 168 is not a perfect square. For making this as a perfect number, adding 1 to this number. So we can add 1 to both of this equation. Then we get here 169 is a perfect number. 169 is the square root of the number 13. That is, the right side is a perfect number. Left side is also a perfect term. We compare this with the identity a plus b the whole square equal a square plus 2ab plus b square. From this we get x square plus 2x plus 1 equal x plus 1 the whole square. Therefore, x plus 1 the whole square equal 169. Here, this equation have left side and right side. Both sides are perfect squares. Therefore, we take square root of both sides. We get x plus 1 equal 169. That is, x plus 1 equal 13. Therefore, x equal 13 minus 1 equal 12. Therefore, solution of this equation is x equal 12. All the second degree equations have two square roots or two solutions. Here we get one solution, that is x plus 1 equal 13. All the square numbers have two square roots. One is a positive number and another is the negative of that number. That is, root 169 equal plus 13 or negative 13. That is, 13 into 13 equal 169. Also, negative 13 into negative 13 equal 169. We are getting x plus 1 equal root 169. Therefore, x plus 1 equal Therefore, x plus 1 equal plus or minus 13. X plus 1 equal plus 13 or x plus 1 equal minus 13. X equal plus 13 minus 1 equal 12 or x equal negative 13 minus 1 equal negative 14. That is, this equation have two solutions, x equal 12 and x equal negative 14. If we substitute the value of x in this equation, we get 12 square plus 2 into 12 minus 168 equal 0. 12 square is 144 plus 2 into 12 is 24 minus 168 equals 0. By adding these two numbers, we get 168. 168 minus 168 equals 0. That is, the value x equal 12 satisfies this equation. Similarly, we write x equal negative 14. We substitute x is equal to minus 14 in this equation. Minus 14 square plus 2 into minus 14 minus 168 equal 0. Negative 14 square is 196. 196 plus 2 into negative 14 is negative 28. Minus 168 equals 0. 196 minus 28 is 168. Minus 168 equals 0. That is, for the value x equal negative 14 also satisfies this equation. For finding the solution of this equation, we write this equation as x square plus 2x equal 168. The next step is x square plus 2x plus 1 equal 168 plus 1. From this we get x square plus 2x plus 1 equal 169. We add 1 to both sides for getting both sides of this equation as perfect squares. That is, 169 is a perfect square, x square plus 2x plus 1 is also a perfect square. This method is known as completing the square method. We look how to find the solution of a second degree equation. Ax square plus bx plus c equals 0 is the general form of a second degree equation. To find the solution of this equation, we can write the constant term on the right side of the equation. By completing the square method, the coefficient of x square is always 1. By making this the coefficient as 1, we divide the whole equation with a. In completing the square method, we add the square of half the coefficient of x to both sides. That is, the coefficient of x is b by a. Half of b by a is b by 2a. Therefore, the square of b by 2a is b by 2a the whole square on both sides. Now, the left side is a perfect square. It is the square of x plus b by 2a the whole square. By simplifying this, b by 2a the whole square plus minus c by a equal b square by 4a square minus c by a equal ab square minus 4a square c by 4a square into a equal a into b square minus 4ac by 4a square into a equal b square minus 4ac by 4a square. Taking square root on both sides, x plus b by 2a equal root of b square minus 4ac by 4a square. Root of b square minus 4ac by 4a square equal root of b square minus 4ac by root of 4a square equal root of b square minus 4ac by plus or minus 2a, that is equal to plus or minus root of b square minus 4ac by 2a. X plus b by 2a equal plus or minus root of b square minus 4ac by 2a. Therefore, x equal minus b by 2a plus or minus root of b square minus 4ac by 2a. These two fractions have the same denominator 2a. By simplifying this, we get the numerator as minus b plus or minus root of b square minus 4ac by 2a as the solution of this equation. That is, the solution of this equation has two roots. One is minus b plus root of b square minus 4ac by 2a, and another is minus b minus root of b square minus 4ac by 2a.
Let us see a problem. The perimeter of a rectangle is 42 meter and its diagonal is 15 meter. What are the lengths of its sides? Perimeter is double the sum of the lengths of the sides. 2 into length plus width equals 42 meter. Length plus width equals 42 divided by 2 equals 21 meter. X plus 21 minus x equals 21 meter. According to Pythagoras theorem, hypotenuse squared equals base squared plus altitude squared. X squared plus 21 minus x all squared equals 15 squared. X squared plus 441 minus 42x plus x squared equals 225. 2x squared minus 42x plus 441 minus 225 equals 0. 2x squared minus 42x plus 216 equals 0. X squared minus 21x plus 108 equals 0. X equals b plus or minus root of b squared minus 4ac by 2a. A equals 1, b equals minus 21, c equals 108. X equals 21 plus or minus root of 21 squared minus 4 into 108 divided by 2 into 1 equals 21 plus or minus root of 441 minus 432 divided by 2 equals 21 plus or minus root 9 divided by 2 equals 21 plus or minus 3 divided by 2. X equals 21 plus 3 divided by 2 equals 12. X equals 21 minus 3 divided by 2. X equals 9. Therefore, x equals 12 or 9. Lengths of the sides of the rectangle are 12 and 9.
We learned about the fourth chapter of the 10th standard part 1, that is the second degree equations. In this, we first study about the square problem. Other two important part of this chapter is completing the square method and formula for finding the solution of a second degree equation. For completing the square method, we add the square of half the coefficient of the first degree term of the equation on both sides. For finding the solution of a second degree equation, we first make the constant term to the right side of the equation and then make the coefficient of x square as 1. For this, we divide the whole equation with the coefficient of x square. This is an important chapter, an interesting chapter, and also it is very useful for your further studies.